Hey everyone, we're still doing tea time with Dave and Nick, and at this point we're going to show you how to get this workload that we've deployed available. Nick, how's it going?
Good. So I'm going to pop up the simulator here, which allows us to see all the steps that we've taken so far, just to recap. So as we talk, we're deploying a highly available workload into a customer edge. So we deployed a site, we created a virtual site on AWS VPC with multiple nodes, and then we created a VKS virtual Kubernetes cluster, run a Helm chart to deploy PostgreSQL on multiple pods, and now we had PostgreSQL up and running. So as David was saying, now that we have the workload running, we need to expose the services to the internet. In this case, we're creating a TCP load balancer. But this last step, advertising load balancer on RE, this is maybe, Dave, back to you.
Yeah, no problem. So what we're doing here is we're creating a TCP load balancer. This is running in the distributed cloud platform. Then we're going to add in our origin pool. Now the origin pool is what runs on the CE, that's where our database is. The TCP load balancer runs in distributed cloud. And what we're going to do here now is basically advertise the TCP load balancer into the RE so that our front-end web app is able to connect to the back-end database workload.
All right, so in a nutshell, all you're doing is just configuring these different load balancers that are all virtual available. You can have an HTTP load balancer, a TCP load balancer, origin pools, and then advertising is just a way to make sure it's available from other services. In our case, we are using Regional Edge to deploy a service that pulls the PostgreSQL data and exposes it to the end user. So
that's right.
Right? Am I getting it correctly here, more or less?
That's it, exactly.
All right, and because we're using TCP load balancer just for a demo purpose, because this is a sort of maybe an internal brownfield legacy application type of scenario, you expose a service, database service, or backend service as a kind of a networking construct, probably easy to understand. Let's talk about deploying to the RE.
Yeah, so deploying to the RE, what we're going to do next is we're going to set up a workload for the front end part of the app. We're going to have a local origin pool, and then we're going to basically call out to that TCP load balancer VIP that we've already pre-configured. The final step here is then to create an HTTP load balancer on the RE with a VIP that we're going to advertise to the internet, and that's where our users come in.
And we're deploying the open source Nginx here as a reverse proxy just because it's using OpenResty module to pull the data from our PostgreSQL database. So it's kind of handy. Obviously, you can have whatever the application services you would expose to the front end for the end users. And this is not the right way to, obviously, in production to work with a PostgreSQL database. But it's a very handy example because we can quickly configure a Docker file for our Nginx reverse proxy with Resty, provide the, in this case, the credentials to connect to the PostgreSQL server. And once these values are updating, again, we're using Helm chart to deploy the reverse proxy and finish the configuration of the Nginx reverse proxy in just a matter of seconds.
All right, so now that we got the Nginx chart deployed and the workload running, just pop over to the cluster view, and we can take a look at how that application's performing. Right here we can see our Kubernetes cluster, we can see what workloads are running, what's being built out, and what the resources consumed are. This is very easy to pull out within the distributed cloud console, and it's something that is unique to distributed cloud, being able to have this level of app visibility and something that also provides the infrastructure.
Right, and I would imagine this is also where you can look at the traffic flows across the different networking constructs that you have, the TCP load balancer, HTTP load balancer. All right, it looks like our Nginx reverse proxy is up and running here, but as a user now, how do I get to this? And you alluded to this earlier, we're deploying an HTTP load balancer. How about you walk us through the last couple steps?
So once we create our HTTP load balancer, we need to add in our origin pool. That's the pool that's running that we just created and deployed in the RE. And then we're going to basically, once the final step here, once the origin pool has been added into the HTTP load balancer, we'll then go down and advertise the load balancer out to the internet. So the first step here is to add in the origin pool. Because this is running virtual Kubernetes, we can basically say exactly what service name that we want to connect the load balancer to in the origin pool in order to make it discoverable. This gives the great flexibility because if the pod needs to restart, the IP address changes, service discovery is inherently built into the origin pool in this configuration.
Sweet. That is really powerful. And I would imagine that's the value of multi-cloud networking across multiple clouds, because a single model like this could be applied to any CE, any RE, and therefore inherently is a way to abstract all of the different ways that different cloud providers are configuring their networks. Even though they're similar, they're not quite the same.
Exactly.
So here we go. Our HTTP load balancer is up and running. And in a second, we'll be able to take our DNS info for this service and access it via the ves-io URL. And of course, we already had that query configured ahead of time in the Docker file. And there it is. It's our PostgreSQL data. Sweet.
Yeah, one of the cool things that you can see with this dashboard also is what site's connecting where. So now that we have user traffic hitting the application, we can actually see additional REs connecting into our TCP load balancer and from the TCP load balancer down into our HA database. And this gives us a real quick and easy way to see where the source traffic is coming from and where it's running to.
Nice. And all single console to configure all of our topology, so all our architecture, which, again, to recap, we did a highly available database on PostgreSQL inside a customer edge site deployment. And then we used the TCP load balancer to expose that to a regional edge deployment, which is where the end users are going. All within a scope of one quick reference architecture, easy to deploy, easy to manage. Any last words?
Sure. Yeah, I just did an article on this. It was super easy to do. I'm really excited about how simple it was to do and complete this myself. So I encourage everyone else to go ahead and give it a try themselves. Check out the article, get your hands on, and see for yourself just how easy it is to get this application running across different platforms.
And a couple resources in the description for the simulator and the guide, which is what you can use to do it for your own infrastructure. Hey, thanks, Dave, for joining me today with our tea time. On the next series, we'll be very excited to talk about another cool project coming up related to AppStack and a retail branch scenario that we're still working on. Thanks, Dave. Talk soon.
All right, thanks.